Hello, in this lecture we are going to start discussion on plotting, and the first topic is two-dimensional plots. So let's begin. So these are the basic functions, basic plotting functions that you can use to plot a graph and add different titles and labels to it. And the first function itself is plot, that creates an XY plot, and this is the syntax for plotting a simple graph. The second function we have got is title, that adds a title to a plot, and this is the syntax that you have to type the title, and in the round brackets and in inverted commas you have to add the text. The next one is the X label, that adds label to the X-axis, then Y label, that adds label to the Y-axis. Then we have got the grid function that adds grid to your graph, and here you can see if we type grid or grid on, it will directly add the grid to your graph. It doesn't require that you type on or not. And the next function is pause, that pause the execution of program so that you can view your graph, analyze your graph. So this type of function is actually used in, for example, you have a temperature sensor and MATLAB is plotting different temperatures on the real-time axis. Then you can use this function, pause function, to pause the time or to pause the graph so that you can easily analyze and observe what is drawing on your graph. So this type of function is actually used when your graph is time dependent. Now the next function we have got is figure, and figure is used to plot different graphs. For example, when you are plotting a single graph, that is figure number 1, and then if you want to plot another graph, then you have to use figure 2, or you have to type figure 2 so that you can generate another graph or you can show the another graph. Otherwise what will happen, that the figure number 1 will be skipped and it will only show you the figure number 2. So you have to use figure function so that you can display multiple plots. And the last one is the hold function, that frees the current plot so that you can add additional plots to it. So this function is used when you have to show multiple plots on the same graph. For example, if you want to plot sine and cosine on the same graph, then you have to use this hold function first and then you have to plot the cosine function. So this is the syntax, hold on, and when you are done you can use the hold off command also. So now let's see how you can use these all function when you are plotting a graph. So let's jump into the MATLAB. So from this lecture we are going to start working on the new script so that it would be easier to type different commands. So here I click on new script, and now from here we are going to type our commands. So first we are going to define axis, x and y axis, then we are going to plot the function. So here I'm going to take a simple example of a person traveling distance in time. So variable x is for time from 0 with a gap of 2 seconds and from 0 to 10 seconds, and y is the distance that is covered by a person, and here I will make a vector. So here I have added 6 numbers. You can also see that it has started from 0, and that is why I have added 6 numbers in the variable y. Now I will use the plot function. Plot. First I will add the variable x and then variable y. I will run it, and now it is asking me to save the file, and I am saving it as test. So here I have got a simple error. Now I will run this command, and here we have got a simple plot. So here you can see we have plot the distance covered by person in time. So now we will add title, x and y labels, grid to make it more proper so that we can easily analyze the graph. Now to add a title, I will type title. Here I have typed distance time plot. For the X label, which is time axis, time in seconds, and Y label is the distance in meters. And we will also add grid. Now let's see how our graph looks like. So here you can see we have added grid, the X and Y label, and the title. Now we will see how to use figure and hold function. So first we will see how to use figure function. So if I create another variable and I type another function, I want to plot another graph, then I have to use the figure function. So how you can use it? For example, I take another function z and I plot sine x, for example, and I will use the plot function again, x and z. Now I will run it. So you can see that we have plot some sort of sine function, but the thing which is to be concerned is that we have skipped our first plot. We have not skipped, but the MATLAB skips the first plot. So what should be done is that we have to use the figure function. So here I will type figure 2, and now I will run this again, and here you can see we have got two figures. Figure 1 is our distance time plot, and the second one is a simple sine plot. Now you have to also add another grid and X and Y label and also the title. So this is the extra work. But what if we want to add the same graph on the first figure? That is, if we want to plot this sine function on figure 1, then we have to use the hold function. So how we can use this? Let's see. So before plot, I will use hold on command, and now I will run it. You can see we have plot two graphs or two plots on a same graph, the sine plot and the distance time plot. Let's take another example of sine and cosine, then it would be much easier to understand. So let's delete and create a new function. First I define the time axis for the x-axis from 0 with a separation of 0.01. I have taken very small distance so that we can easily observe a sine graph. Otherwise it would be like what we have made before, to 10, and here I create another variable for sine t and y for cos t. Now I will use the hold function, hold on, and now I will use plot tx, and you can also add two more variables in the same function like t comma y. Now I will run it. Here you can see we have added two functions on the same graph. Now let's add title and grid. Make sure and keep in mind that all the titles, x and y labels are after the plot function. And here it looks much better. So now let's move on and let's see what new functions we have got. So here we have got mark and color options. You can see that we have got line type options, point type options, and color options. So line type is basically the space between 2 points, and the space between 2 points is covered or connected by this line, and these are the point types. These are the point types that you can use, which means at different points the values are placed. So these points are indicated by these indicators, and here we have got the color for the indicators. So let's see how we can add all these options, all these indicators in our graph. So if I want to add a different type of line and indicator on the sine wave, then I will just enter another comma, and in inverted commas I will add the line type colon and point type this O, and the color I will add blue. You can see here I have added the line type this colon and the point type O for the circle and the color type blue. So here in the inverted comma you can add all these three things together, and for the cosine in the inverted comma I will add the line type dot or dash, and for the point indicator X, and for the color M for magenta. Now we will run this script, and here you can see that it's all matched up and we cannot see the lines and all these things. The reason behind it is that we have kept very small spacing. If you can zoom in, you can see this, all the lines, and also you can see the points which are represented by X, and the line is represented by dash. On more zooming in, you can also see the X and the dashes for the line. But if I change the spacing to 0.05 or 0.5, then you could easily see all the dots and all the indicators. And here we have got, so you can see that all the points are represented by circles, lines by dashes, and its color is blue, the sine wave, and the cosine wave, the dots are represented by cross, lines are represented by dashes, and its color is magenta. So in this way you can use all the indicators so that you can easily make a difference between all these waves. Now let's move on. So here we have got functions for axis scaling and annotating plots, and the first function is axis. So when the axis function is used without input, it freezes the axis at the current configuration. Executing the function a second time returns axis control to the MATLAB. So using this function it will freeze the access at the current configuration. What configuration you have made for your access, it will freeze on it. The next function is the access with inputs. So access with inputs will configure your access, and in that access your plots will be made. For example, you have to add the x minimum, what is the minimum limit for the x-axis, and the maximum limit for the x-axis. Similarly, the y minimum and y maximum, and this function we will see on MATLAB. The next function is the access equal, forces the scaling on the x and y axis to be same. Using this function, the x and y axis will be equal. Next function is the legend, that allows you to add a legend to your graph. The legend shows a sample of a line and list of string that you have specified. Actually, it shows that what type of line or what type of wave you have made, and it is also a string, it is also text which is displayed on the graph. We will also see this. Here we have got the text function, and you can add text to your graph. You have to define the x coordinate, y coordinate, and then you have to add your text, which is string. And the last function we have got is the gtext, which is actually text, but it is added on the user's demand. Where the text should be added on your graph, you have to click on it. You have to click on that point in the graph that at this point the text should be added. Now we will see how to use these functions. So after this function, I will add the access function. In the round bracket, I will add the square brackets. Now I will first add the x minimum value, which should be from -1, for example, and the x maximum should be 11. Y minimum should be -2 and y maximum should be +2. Now let's see how it looks like. I run this. Now you can see that I have defined the axis for this graph, and under this axis this graph is plotted. So you can use this axis command to plot your function wherever you want and from where it should be started. Now you can also use the axis equal function, and to use that, just remove this and type equal. So you can see that it has not applied the function properly, that the x and y limits, the x and y axis should be same. But if I used the different function like the distance time plot, then you can easily see the axis that would be equal. So I show you. Now you can see that when I have changed the function from sign to this simple vector, then you can see that it has same axis, same x and y axis. So in this way you can use this function. Now I will show you how you can add legend to your graph. Legend will be shown over here on the top, and it will show what type of line it is. So I show you how you can add it. And here you can see I have added a legend which shows that this type of line is for what. And here you can see I have added a legend. Now let's see how to add a text and gtext. So first type text, and in the round bracket enter the variable for the x coordinate, which is t, then add a variable for the y-axis, which is x, and then add a text. I will type, for example, points, and here you can see on each point it has added a text. So in this way you can use this function. And if you add a gtext, like this. Now you can add text to any point on this line or anywhere in the graph. For example, on this point, you can see only on this point I have added a text. So this is the difference between a simple text function and the gtext. Now I will show you a special type of plot, and for that first I will clear this. Now a special type of plot is peaks, and in the bracket, for example, 100. So what type of plot it will make is that it will create a 100 by 100 matrix, and it will plot that matrix in a graph. So let's see what would display. Here you can see we have plotted a 100 by 100 matrix on a graph. So this is just for information, a sort of information that I want to share you. Now we will discuss how you can plot a complex value which has real and imaginary. I create a complex number, complex vector containing different complex numbers, and here I type a complex number 0 plus 0i, and I will type few more. Like this. Now I will plot this complex vector, and here you can see I have plotted the complex number, and here we have got the positive, or you can say real x-axis and imaginary y-axis. So this y-axis has all the imaginary values and this x-axis contains all the real values. If you plot more than one complex vector, then it will only plot the real number. For example, if I create another vector, complex vector b, and here in the plot I will add another variable, and here you can see only the real values are plotted, and you can see in the command window also that imaginary parts of complex x and y are ignored, so only the real values are plotted. So these are the exercise questions that I want you to solve them, and they are very simple and related to our discussion that we have done. If you have any questions, you may ask me in the comments. So thanks for watching and see you in the next one.